So we will start a new paper, paper number 1, calculus of several variables. And the first chapter is limit and continuity of multivariable functions, or limit and continuity of these several variable functions. So definition of limit: let fxy be function of two variables. So fxy, if we write fx comma y comma z, then it is a function of three variables. In this way, we have to study the multivariable function, that is two variable functions, three variable functions, that limit and continuity and differentiation and integration. So here is fxy is what is function of two variables. Then we say fxy, uh, limit of fxy as xy tends to ab is L. Then limit of fxy as xy tends to ab is L if for every epsilon greater than 0 there exists delta greater than 0, such that mod fxy minus L is less than epsilon whenever root x minus a bracket square plus y minus b bracket square is less than delta. So this is the definition of the uh, limit of two variable function. Similarly, we can define three variable function f x y z as x y z tends to abc is L if and only this is less than epsilon whenever root x minus a bracket square plus y minus b bracket square plus c minus z minus c bracket square is less than delta. So this is the definition of two variable function, limit of two variable function. So when we say the limit of the function exists, if the limit if this limit exists, if limit along all possible paths that are infinitely many, obviously, from xy to ab are set. So in previous year in F.Y.B.Sc, what is the definition of a limit of function of one variable? That the function is fx, and then limit x tends to a fx is equal to L if this definition, that mod fxy minus L is less than epsilon whenever, and when this limit exists, limit x tends to a, we know that if the right hand limit, that is limit x tends to a plus, and the left hand limit x tends to a minus, both exist and are equal, then we say the limit of the function exists, because x tends to a means x tends to either from right side of a or left side of a. There are two ways in the in that two ways x tends to a, that is from right side. If the x tends to a from right side, then we say x tends to a plus, and if x tends to a from left side, then we say x tends to a minus. That is, left hand limit and right hand limits are equal, because the x tends to a in only two way, that is x tends to a from right side or left side. But here the xy is the point in the xy plane, and it tends to ab in the straight way or in the uh, different way. That is, there are many ways in parabolic action or in the zigzag motion. Then xy tends to ab, there are infinitely many paths through that paths, along that paths xy tends to ab. But in single variable function, x tends to a only from two sides, and if we check that two limits, and if they are equal, that is right hand limit and left hand limit, then the limit of the function, single variable function, exists. But here we have to find the limit along all possible paths, and there are infinitely many ways. So this is very tough job to find the limit along all paths, and that's why uh, it is not only that find right hand limit and left hand limit, it is for single variable function. So what is the note, that when this limit xy tends to ab of fxy exists, if limits along all possible paths, and that are infinitely many, from xy to ab are set. This note in the F.Y.B.Sc is what? Limit x tends to a fx exists if limit along two paths, that is x tends to a plus and x tends to a minus, are set, because there are only two paths that's along that x tends to a, that is from right side or from left side. But here xy tends to ab There are infinitely many paths, and that's why we have to find all possible paths, and we have to find the limit along all possible paths, and it's obviously impossible. That's But we can use this note as a negation of this note. That is when this limit does not exist. If limit along any two paths from xy to ab are not equal, then we say the limit does not exist. That is, the limits along different path is different, then limit does not exist. That is, if we have two paths such that from xy to ab, such that their limits along that two paths are different, then we say this limit xy tends to ab if xy does not exist. In F.Y.B.Sc, if the right hand limit and left hand limit only, there are only two limits are equal, then we say limits exist. And if these right hand limit and left hand limit of the single variable function are equal, not equal, then we say the limit does not exist. But here, if we find two paths and along that two paths, suppose the limit are same, then we cannot say that this limit xy tends to ab of this two variable function exists. So when the limit exists, limit along the two paths or three paths or four paths are same, then we cannot say the limit exists. Limit along all possible paths, and that are infinitely many. That is, in order to show the limit exists, this way is not useful. That find limits along two paths or three paths or five paths, and all the limits are equal, and therefore the limit simultaneous. This is called simultaneous limit. Xy tends to ab. It's called simultaneous limit. This is the definition of simultaneous limit. So the question is what? Define simultaneous limit of the function fxy. So this is the definition of simultaneous limit. It's called limit or simultaneous limit. So when the function limit of the function fxy does not exist, xy tends to ab. If we have two paths, if we find two paths such that xy tends to ab, along that two paths are not equal, the limits are not equal, then we say the limit does not exist. That is, if the limit along different path is different, then limit does not exist. So we will solve two types examples. That is, first we will see the examples in that examples limit does not exist, and in the second part we see the example in which the limit exists. That is, how we can show the limit exists, we use these definitions. Okay, and how we can show the limit does not exist, we can use this note number 2. So in order to show the limit exists, use a definition, and in order to show the limit does not exist, use the note number 2. So first we will see the example on the note number 2. That is the example in which the limit does not exist. So evaluate. The question is what? Evaluate limit xy tends to 0, 0 of this if exists. So if exists, then fine. So this function xy divided by x square plus y square is fxy, suppose. Then we will find the limit along path y is equal to x. So limit xy tends to 0, 0 fxy is equal to, so replace y by x. So what do we have? Fxy is fxx. Limit xy tends to 0, 0 replaced by x tends to 0, because y is converted to x. And then what is fxx? This is fxy. This is fxy. So fxx is what? Replace y by x. Then we have this answer, and that is x square by 2x square is 1/2. And then limit of 1/2 is what? Limit of 1/2 is 1/2. So this answer right here is equal to 1/2. Right here is equal to 1/2. So this is the limit along path y is equal to x. Then we will find the limit along path y is equal to 2x. Same limit, that xy tends to 0, 0 xy is equal to limit x tends to 0 f of x to x. Replace y by 2x. Then fx to x is what? Replace here y by 2x. Then x into 2x divided by x square plus 2x square, 2x bracket square is 4x square. And then we have this is 2 by 5, and the limit of 2 by 5 is 2 by 5. And that is along the path y is equal to 2x. This limit is what? Limit xy tends to 0, 0 fxy is 2 by 5. And along path y is equal to x, the limit is 1/2. And therefore we say that limit along different path is different. And therefore limit xy tends to 0, 0 fxy does not exist. Okay. So this is the one way of the proof or solution of this example. We can also give the proof or solution of this example by using this. This is the second method. That is, we we find the limit along path y is equal to mx. So what is the limit along path y is equal to mx? Limit xy tends to 0, 0 of xy is equal to limit x tends to 0 f x mx. That is replace y by mx. And then we have limit x tends to 0 f of x mx. This is fxy. This is fxy. That xy divided by x square plus y square. So f x mx is what? This is x into mx plus x square mx bracket square means m square x square. And then take x square as a common in the denominator and then cancel the x square. And the limit is x tends to 0 of m by 1 plus m square is what? M by 1 plus m square, because this m by 1 plus m square is independent of limit. Limit is on x, that is this constant with respect to limit. And so we have it is equal to m by 1 plus m square, which depends on m. That's why what happened, this depends on m, then that is if we change m, that is if we take m, then we have answer 1 plus 1 plus 1 square, that is 1 half answer. If we take m as 2, then we have answer 2 by 1 plus m square, 2 square, that is 4 plus 1, that is 5, 2 by 5. If we take change m, then we have the answer 3 by 10, 3 by 10. In this way, if we change m, then we have the different answers. If this limit does not depend on m, then what's happened? Suppose here we have the answer 5. Then if we change m, that is if we change path, then the limit remains same. And that's not worse. That is not useful to show the limit along different path is different. When limit along different path is different, if this answer is depend on m, if this answer is not depend on m, then we cannot say that limit along different path is different. Because if we change m, then answer remains same if it is not depend on m. But here what happen, if the answer is depend on m, then what happen, if m change, then answer that is the limit along that path is a different change. And that's why either use this method, use to find two separate paths along that the limit are different, or either use this method, that is find limit along path that includes m notation. This is not fixed path. That for another example, we can use y is equal to mx square or x is equal to my. There are different paths. We find out path such a way that we have the answer depend on m. Okay, or this is the first method, that either find two paths, different paths, such that along that limits are this limit along that two paths are different. So we can use this method, the first method or second method. So we will use mostly the second method, that is take the path in terms of m and find answer depend on m. If this answer does not depend on m, we have zero answer or some constant number, then we cannot say that the limit along different path is different. So take care that the answer of the limit is depend on m. Or another method is what? Use the two paths, or find two paths such that their limit along that two paths are different. So now second, next is what? Right, that limit along different path is different. So which depends on m. So limit along different path is different. Write the sentence what? After this, write sentence that limit along different path is different, and therefore limit, write this, limit along different path is different. After this, which depends on m, write then limit along different path is different, and therefore limit of fxy as xy tends to 0, 0 does not exist. Write this sentence after this. Then third example, evaluate limit xy tends to 0, 0 to xy square divided by x square plus y raised to 4 if exist. So we will find the two different paths that the limit along that two paths are different, or we can find a path in terms of m, so that the limit along that path is depends on m. So that path is what? Y is equal to root mx, or x is equal to my square, or y square is equal to mx. Y square is equal to mx. Take any path. Y square is equal to mx. So solve this by using taking limit along path y is equal to root mx. So limit, simultaneous limit xy tends to 0 0 fxy is equal to if we have to substitute there y is equal to root mx. Therefore x tends to 0, f of x root mx, and therefore substitute y as root mx here, y as root mx. Then what we have, y square is emx, and then y square is what, y raised to 4 is what, y raised to 4 is root mx square, bracket raised to 4 is what, m square x square. So here substitute y as root mx, and then what we have, the numerator, take x square as common from denominator and cancel this x square. We have the answer 2m divided by, and its root, its limit is what, 2m divided by 1 plus m square, because this is constant with respect to limit. Limit is on x and this is the quantity in m, and which depends on m, and therefore limit along different path is different, and therefore limit, this limit xy tends to 0 0, 2xy square divided by x square plus y raised square, y raised to 4 does not exist. Therefore the given limit does not exist. So take y is equal to mx root mx path, or x is equal to my square. That is, if you take x is equal to y my square, then this is limit y tends to 0, f in right here x as my square comma y, and then we have the answer depend on here. So this is the problem on a range and domain. We will see these problems after completion of the limit chapter, limit topic. So here is the continuity or continuous function, continuity of the two variable function. So fxy is called continuous at ab if limit xy tends to ab, fxy exists and is equal to f of ab. So when we say the function fxy is continuous at ab if limit xy tends to ab, fxy exists and is equal to f of ab. So the problem is this. Suppose the same problem, the first number problem. Here is xy divided by x square plus y square. Here is 2xy divided by x square plus y square. Obviously, this limit again does not exist. Here is the 2xy divided by x square plus y square. The given function is what? fxy is 2x square divided by 2xy divided by x square plus y square. If xy, order pair xy is not equal to 0 0 and is equal to 0, if xy is equal to 0 0 at 0 0. So I have to discuss the continuity at 0 0, and we know that when the function fxy is continuous at 0 0, if limit xy tends to 0 0, fxy exists and is equal to f of 0 0. That is, if this limit xy tends to 0 0, fxy does not exist, then the function is not continuous at 0 0. So first we show this limit xy tends to 0 0, fxy either does not exist, or if it exists, then show it is by using the definition. So here the problem 2xy divided by x square plus y square, we will find this limit xy tends to 0 0 fxy along path y is equal to mx. So limit xy tends to 0 0 fxy is what? Limit x tends to 0, f of x mx, substitute y as mx, and then we have this answer 2m divided by 1 plus, which depends on m, and therefore limit along different path is different, and therefore limit xy tends to 0 0 fxy does not exist, and therefore fxy is not continuous at 0 0. That is answer of the limit does not exist and this function not continuous at 0 0, both are same. That is, instead of this function, if we are given this function, that what is the function, that 2xy square divided by x square plus y square, then same proof that limit does not exist, and therefore the function fxy, this function fxy is not continuous at 0 0. That is, just write one more sentence that first show the limit does not exist, and then write that limit does not exist, therefore the function is not continuous. Because when the function is continuous at ab, if limit xy tends to ab, fxy exists, first it is exist and then is equal to f of ab. So when the function is not continuous at ab, if either this limit does not exist, but or if this limit exists but it is not equal to f of ab, then what is f of 0 0 here? Here is 0. If this limit exists and it is not equal to 0, then it is also not continuous. But here the first condition that this function is not the limit of this function at 0 0 does not exist, and therefore fxy is non-continuous or not continuous at 0 0 or discontinuous at 0 0. Okay, the next example, x square minus y square divided by x square plus y square. Again, the question is what? Either the question is evaluate limit of this x square minus y square divided by x square plus y square as xy tends to 0 0 if exist, or the question is what? This is the given function, and the question is discuss the continuity at 0 0. So the function fxy is continuous at 0 0 if limit xy tends to 0 0 fxy exists and is equal to f of 0 0. So we will find limit xy tends to 0 0 fxy. If it exists, right here comma and then write if exists. We will find it, but when if it is exist. So along path y is equal to mx, this limit xy tends to 0 0 xy is what? Limit x tends to 0, write y as mx. And then f of x mx is what? This is fxy. So f x mx is replace y by x mx. So x square minus m square x square plus m square x square. And then take x square common from numerator and denominator. We have this answer. And limit of x tends to 0 of this quantity is itself, because this is constant with respect to limit. So 1 minus m square, here I write numerator as 1 minus m square, denominator as 1 plus m square, which depends on m, and therefore limit along different path is different, and therefore limit xy tends to 0 0 fxy does not exist. Okay, and therefore fxy is not continuous at 0 0. So this is the example, these are the examples of continuous functions, not continuous functions, limit exists, limit does not exist. That is the answer of the limit exists and the continuous function are same. And if the limit does not exist, then function is not continuous, discontinuous at that point, 0 0. And that is the answer of the not continuous problem and answer of the limit does not exist. Both answers are same. Just write one more sentence that therefore the function is not continuous at that point. And then the next, this limit xy tends to 0 0 fxy, or limit xy tends to ab fxy is called simultaneous limit. Okay, and that is the first definition of this paper, that is simultaneous limit. Limit xy tends to 0 0 or limit xy tends to ab fxy is called simultaneous limit. And repeated limit, these are called repeated limit. Limit x tends to 0, limit y tends to 0 fxy, or limit y tends to 0, x tends to 0 fxy. These are two are the simultaneous limit. Here first take the limit as x tends to 0 and then take y tends to 0. Here that is the separate limit. Here is the separate limit. Either first find limit with respect to as y tends to 0 or y tends to b, then find limit as x tends to 0 or x tends to a. In this simultaneous limit, at a time xy tends to 0 0 or ab. Okay, here is x tends to a and y tends to, the xy tends to ab means x tends to a and y tends to b, but simultaneously. Here is x tends to a and y tends to b repeatedly. So these are called repeated limits, and there is no connection in the simultaneous and repeated limits. That is, the repeated limits exist, does not exist, that is not depend on simultaneous limit. So we will see the problems on the repeated limits and simultaneous limit, remaining problems in the next lecture.